Hey everyone. So today I'm making this video for your formatives FA, correct? So I will try to cover all the topics which are there in the formatives. So let us start. The first topic is motion. So what are important things related to motion? So in motion, you must first know what is a scalar quantity and what is a vector quantity. Scalar quantity has only magnitude. Vector quantity has both magnitude and direction. Okay. And speed is a scalar quantity. Velocity is a vector quantity. Mass is a scalar quantity. Weight is a vector quantity. Force is a vector quantity. Pressure is a scalar quantity. Yeah, and so on and so forth. You can think about it. In graphs, whenever we talk about graphs, if it's a displacement time graph, and if it looks like this, time will always be on the x-axis because it is independent variable. If a displacement time graph looks like this, then it means the body is stationary. It is not moving with constant velocity. Okay, it is stationary. The displacement is not changing. And if it looks like this in displacement time graph, then it's moving with constant velocity. And to find that velocity, we find slope of gradient of this curve. Okay, y2 minus y1 upon x2 minus x1. So the gradient or the slope will give you the velocity, which will be y2 minus y1 over x2 minus x1. And if the graph looks like this, then it is an accelerated motion and you really can't do anything about it. Okay. Then let us come to, we did velocity. Let us come to something else. Velocity time graph, right? So if it's a velocity time graph, so this would mean it's constant velocity or zero acceleration. Okay. Zero acceleration. This would mean constant acceleration. And how do you find the acceleration? Again, you find the gradient. Gradient will give you the acceleration. And gradient, how do we find gradient? Y2 minus y1 over x2 minus x1. And if it looks like this, then it's a constant deceleration. Constant deceleration. And if it is like this, then it is accelerated, but we don't know the acceleration. This is accelerated. In such graph, they will just tell you to find this thing. They'll tell you to find acceleration at a given point. So if they tell you to find acceleration at this point, let us say this is time 5 seconds, and they tell you to find acceleration at 5 seconds, what you do is you make a tangent here using your scale, you make a tangent here, take any 2 points on the tangent, okay? Take any 2 points on the tangent and you'll and find its gradient of the tangent, y2 minus y1 upon x2 minus x1, x2 y2 x1 y1, you will get the slope. You will get the acceleration, okay? And if they want you to find the distance covered, you find the area under the curve. Like here, this is the distance. Here, this entire thing is the distance. So here we will remember that slope or the gradient in velocity time graph gives you the acceleration, and the area under the curve is given by area under the curve gives you the distance. Okay. Okay. Now, as we know, velocity or speed is distance upon time. Speed is distance over time. Speed is distance upon time, or velocity is displacement upon time. Acceleration is change in velocity upon time. Remember this, okay? Acceleration is change in velocity upon time. U is the initial velocity, V is the final velocity. And whenever a body is freely falling, or like dropped from somewhere, for a freely falling body, take acceleration equals to acceleration due to gravity, which is G. Okay. And then we come to a few more things. Newton's law. So I'll just tell you the important things, okay? Newton's laws. So in Newton's law, number one thing is that the resultant force is always mass into acceleration. You should remember this. Let us say this body is acted upon by force F1 here and force F2 here, and it is still moving in direction of F1. So the resultant force will be F1 minus F2. Why F1 minus F2? Because it is going in F1 ka direction. If the body went like this, F2, and if this was F1, if body was going like this, then your resultant would have been F2 minus F1. Okay. And always resultant force you can write mass into acceleration. F1 minus F2. Okay. And as we know, if force is equal to mass into acceleration, acceleration will be force upon mass. So acceleration is inversely proportional to mass. So lighter things gain more acceleration. Heavier things gain less acceleration. Also, there is Hooke's law. In Hooke's law, we know that the stress is directly proportional to strain. Or we can say load is directly proportional to extension within the elastic limit or the limit of proportionality. This is known as limit of proportionality, this point. Limit of proportionality. Proportionality or elastic limit. So what does this mean? That if you have a spring or something and you are extending it with a load, this load, let us say mass M and G, so the load is in newtons mg. So the more is the load, the more is the extension till the limit of proportionality. What will happen after that, after limit of proportionality is reached, even if you don't increase the load, the extension will increase. It will go something like this. And if the load is here and extension is on x-axis, it should go like this. Even if you don't increase the load, the extension increases and the wire breaks. And if extension is here in centimeter or meter or even millimeters and load is here, it would look something like this. Extension will increase even if load does not increase. And the formula you use in Hooke's law is F is equal to Kx. Okay. The force is equal to K into extension. F is the load, but in newtons always. X is the extension. K is the spring constant. It is different for different springs. Spring constant, or it is also called as force constant. And the work done will be F into X. So it is load into extension. If the force is constant, okay, only if force constant. If force is not constant, and if they've given you a graph like this, okay, if it's force and extension, and they've given you a graph, if force is not constant, you can say that work done is area under the curve. So like here, you can just do half into base into height. Okay. Then what is momentum? Momentum is basically mass into velocity. Okay. And force is change in momentum upon time. Unit of momentum is kg meter per second. Force according to Newton's law is change in momentum upon time. So force is equal to mv minus mu upon time. Let us say there was initially this body which was moving with velocity u. We applied a force and it started moving with velocity v. So force is mv minus mu upon time. So F is equal to mv minus u upon time. So it is acceleration. F is equal to ma. Okay. One more thing you can do from here. F into time is equal to mv minus mu. So F into time is known as impulse. So impulse is just change in momentum. mv minus mu delta v, and it has the same unit, kg meter per second. Okay. Then there is also something called as moment of force. Acha, before that, in collision problems, whenever there are collision problems, we take total momentum before collision, total momentum before collision equals total momentum after collision. So m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Now, what type of the problems are there? This is body 1, this is body 2, moving with u1, moving with u2. This has mass m1 and mass m2. So this is the total momentum before collision. Momentum of this plus momentum of this. This will be total momentum after collision, m1 v1 plus m2 v2. Because after that, they might stick together, they might go, we don't know. Whatever happens, let us say they both are moving. This is with v1 and this is with v2. And the masses is m1 and m2. Okay. Now here you will have to remember few things. Let us say if there is a wall, and if this thing comes, this a ball hits and its velocity changes, you let us say it came with 3 meters per second and they say it's an elastic collision. So this will go back with 3 meters per second, but you take this direction as negative. Okay, this is very, very important. Okay. If they say that there is a ball of mass, let us say 2 kg, and it hits the wall with 3 meters per second. So what is the change in momentum? And the moment and the collision is perfectly elastic. So what will happen? This wall to has no this thing. This has velocity 0. So momentum, that is initial momentum of wall, is 0. So you'll get mass of the ball into speed of the ball minus 2 into minus 3. Okay. So this will be 6 plus 6. So it will be 12. If you don't do this minus, you will get 0, which will be wrong. Okay. Because the direction is changing now, so you make the velocity negative. This is very, very important. And also whenever they say stick together, if two balls stick together, then they will travel with the same velocity. So you can do m1 u1 plus m2 u2 equals m1 plus m2 into v, because they both have same velocity vv, so we have taken it common outside. Okay. Then there is also moment of force. In moment of force, if this is a pivot and this is a force, we say that moment of force is force into perpendicular distance from pivot. Force into perpendicular distance from pivot. And always we use the law of conservation of momentum. We say total anti-clockwise momentum equals total anti-clockwise moment equals total clockwise moment, right? Total anti-clockwise moment equals total clockwise moment. Let us say if it is balanced here. This is F1, this distance is D1, this is F2, and this distance is D2. So this is rotating it anti-clockwise. So F1 into D1 equals F2 into D2. There can be more forces also. You will have to take it into consideration. Also remember, very important, if it is not hinged at the center, if it is hinged somewhere here, okay, and there is weight of the object, weight of the beam, let us say W, and this is at distance, let us say D1, and this is another force F2 at distance D2, and here we have a force D3, F3 at distance D3. So you will always have to count for this also, okay? F3 times D3 equals W into D1 plus F2 into D2. Okay. And the weight will always act at the center of the beam. So if the beam is like, let us say 100, so W will be at 50. If beam is of like 50, W will be at 25. This is standard, okay? Don't need to worry about that. And always you take the distance from the pivot. Remember this, take the distance of the force from the pivot. And the favorite IGCSE question is, what are the conditions for equilibrium? There are two conditions for equilibrium. Number one, sum of all the forces should be zero. That means total upward forces should be equal to total downward forces. And sum of all the moments of forces should also be zero. That means total anti-clockwise moment should be equal to total clockwise moment. Okay. Unit of moment is Newton meter because it is force into distance. Yeah, I think I've covered pretty much of motion. If anything is remaining, I'll come back to it. Then when we talk about pressure, so pressure is obviously we know force upon area. Unit can be Newton per meter square or pascals. Very important that pressure is a scalar quantity. People think it's a vector quantity, but no, it's a scalar quantity. And whenever there is a liquid column and you want to find the pressure on the base, so pressure by liquid column is H rho G, where H is the height of the liquid column, density of liquid, rho is the density of liquid, and G is acceleration due to gravity. And always add the atmospheric pressure. Whenever they ask total pressure, it will be atmospheric pressure plus the pressure due to the liquid column. Okay. So it will be total pressure will be atmospheric pressure plus H rho G, rho GH, whatever you call it. Okay. हाँ. एक मिनट रुको मम्मी. And whenever there is liquids, whenever there is hydraulics, you can do the pressure is transmitted undiminished. So pressure here will be equal to pressure here. So we can see pressure 1 equals pressure 2. So force 1 upon area 1 equals force 2 upon area 2. You can use this formula. You will see it as a force multiplier because see, if this area is smaller and this area is bigger, so F1 uh, into A2 upon A1 will be F2, right? So if let us say this is twice, this is let us say twice A1, right? So F2 will become 2 times A1 upon A1 into F1. So you see F2 has become twice F1. So this acts as a force multiplier in the hydraulic system. And there shouldn't be bubbles in the hydraulic system. Okay, if there are any bubbles, energy is not transmitted. You will have to push the brake or whatever it is harder. It is not transmitted properly. Uh, when we talk about energy, first we must know what is work. Work is force into displacement. Force into displacement. And it is also again a scalar quantity. Now energy which we have are potential, gravitational potential energy, mgh, kinetic energy, energy due to motion, half mv square, and strain energy. But strain energy, they don't ask any numericals, although it is half kx square, but they don't ask numericals about it. They ask numericals about this only. And see, energy, all these three forms are interconvertible. Okay. S- So if a ball is falling from top and coming down, its potential energy, gravitational potential energy is getting converted to kinetic energy. If it is thrown up, its kinetic energy is getting converted into potential energy. If an object is stopped by a spring, its kinetic energy is getting converted into strain energy, so on and so forth. So you can use it. Uh, then we have power. Power is energy upon time. Unit of power is watt. And we have efficiency. Efficiency is useful power output upon total power input into 100. Mhm. So total power input upon 100. And unit of power is watt. So you can also calculate energy. Na? Energy is power into time. But always this has to be in seconds only. Okay. Don't make it in minutes or hours. Convert it into seconds. Energy should be in joules. Mhm. See, if you throw an object up, okay, its kinetic energy gets converted to potential energy. So half mv square is equal to mgh. So v square is equal to 2gh. So the velocity which it will reach will be 2. Sorry, the height that it will reach will be v square upon 2g. Okay. Similarly, if an object is falling from a height, and see, note this is independent of mass, correct? This is not dependent on mass. So as long as the velocity is same, doesn't matter if it's a heavier object or a lighter object. Like this, they will say that there are two fishes. One is a heavier fish, and they both jump with the same velocity. They will both reach the same height because it is independent of the mass. Similarly, if an object falls, you can do again gravitational potential energy equals kinetic energy. You will get mgh equals half mv square. So we'll get v is equal to under root of 2gh. Correct. So the object at this point, no matter how heavy the object is or light it is, the velocity it gains will be equal to this. Okay. And then we have heat and temperature. So temperature is just the measure of average kinetic energy of a body, measure of average kinetic energy of molecules of body. Or actually, it should be potential energy plus kinetic energy. Potential energy is due to the attraction between molecules, but that's negligible, especially in gases. And kinetic energy is due to vibration. Okay, so if there are many molecules and they are vibrating like this, you take the kinetic energy of each of the molecule, n molecules, and divide it by with the number of molecules. That gives you the temperature. And heat, we know heat is flow of energy. If this is an object at temperature T1, this is at T2, and T1 is higher than T2. Heat flows from T1 to T2. So it is flow of energy due to temperature difference. Unit of heat is joules. And how much heat is to be supplied is given by this formula. Q is equal to mc delta T, where Q is the heat, m is the mass, C is the specific heat capacity, delta T is the change in temperature. So from here, if you want C will be Q upon m delta T. If mass is 1 and delta T is also 1, then C is equal to Q. So this means specific heat capacity is amount of heat required to raise the temperature of unit mass, because there is mass in the denominator, unit mass of a substance by 1 degree Celsius or 1 Kelvin. Okay. And similarly, there is something called as just heat capacity. Just heat capacity is just Q upon T, Q upon delta T. It doesn't have a mass. It doesn't have mass. So no unit mass thing. It is just amount of heat required to raise temperature of full body. Amount of heat required to raise temperature of body by 1 degree Celsius. And see the one who's, let us say if you have two objects, you supply equal amount of heat. Okay. Q and Q. The temperature rise here is 2 degrees Celsius, and here the temperature rise is 10 degrees Celsius. So this has a higher heat capacity. This has a lower specific heat capacity. Okay, because even in small amount of heat, its temperature is rising more. Delta T is more. Okay, because see, Q is directly proportional to delta T. Uh, Q is equal to mc delta T. So C is equal to Q upon m delta T, right? So C is inversely proportional to the rise in temperature or the change in temperature. So the one with the higher temperature rise has less C. Okay. Now we know there are three modes of heat conduction, modes of heat transfer. Conduction is not a good word. They are conduction, convection, and radiation. Now in conduction, what happens if there is a spoon, uh, it is in a flame or something, and you touch it here, you still feel the warmth because what happens? The particles vibrate and they push each other and the vibrations reach us, right? So it happens only in solids. It is the slowest mode. It needs medium, and particles vibrate and transfer their energy. Particles vibrate and collide with the neighboring particles and they transfer their energy. In convection, that doesn't happen. Convection happens in liquids or fluids. In convection, what happens if this is a container? If this part gets heated, the liquid is in layers. Okay, so this layer expands. If it expands, density is mass upon volume. Volume increases, density decreases. So this layer rises up and comes here, and the layer behind it comes down. This happens till the entire liquid has gained same temperature. Each layer get heated up, expand and rise, and the next layer comes down till entire liquid has reached a constant temperature. This happen only in fluids. It also needs medium. It is faster than conduction. And obviously the molecules, they actually leave their place. Molecules go from one place to another. Radiation. So this is sun and there is earth. There is nothing in between. There is just vacuum. Still, radiation from sun reaches the earth. So heat is transferred in form of electromagnetic infrared radiations. And it is the fastest method and it needs no medium. Okay. Also remember, if it's a black object is a good absorber and hence a good emitter also. Okay, this people get confused, but what absorbs good is also good emitter. But if it is a shiny white object, if it's white, it's a bad absorber and hence also a bad emitter. Mm, so is there anything left? We talked about power, energy. Oh. Huh. Also see, if they say 90% of the times energy is lost in friction, okay? Energy, I mean 100% times energy is lost in friction only. So energy is lost in friction. But in 90% of the calculations, we assume that there is no friction, okay? But if it in a question it is given that, let us say they say that there is a ball here and it starts going down. So its potential energy is obviously getting converted into kinetic energy, but it is not just getting converted into kinetic energy. Some energy is also used to overcome this friction. Okay, plus friction. Energy used to overcome friction. You can't say friction because friction is a force, na, and these two things are energy. You can't equate apples and potatoes. So potential energy is kinetic energy plus energy you use to overcome friction. So you can do potential energy is equal to kinetic energy plus work done to overcome friction. Work done and energy is same. Work to overcome friction. So potential energy is equal to kinetic energy plus force, frictional force. They would have given that in the question into the distance. Okay. Always remember because then what do they say? They say that sometimes in question they say that 30% of potential energy is used in friction, used in overcoming friction. So you find the kinetic energy when the ball reaches here, okay? So in this, what you will have to do, you can't take potential equal to kinetic. In this case, it will be wrong. you will have to take 70% of potential is equal to kinetic, because 30% is lost here. 30% is lost here. Only 70% is used here to gain the velocity. Okay. So this is very important. Remember this. Okay. Whenever they say that energy is used, you subtract that energy and then find the velocity or find the height or whatever is given. Okay. I think that's enough. This is a good revision I have made for you. Thank you. Hmm.